In this example, we will parametrize the Cartesian equation 9x squared plus 4y squared plus 24y equals 0 by using x equals h plus a cosine of t and y equals k plus b sine of t. Essentially, what we're going to do when working through this problem is that we're going to have a goal to get this to be equal to something quantity squared plus another thing squared equals 1. That way we can connect that to sine squared of t plus cosine squared of t equals 1, or the Pythagorean identity. If we can conjure or mess with this equation so we can get it to look like this, then we can connect it there and create this set of Cartesian equations. However, we do need to do some maneuvering in order to get to that point, because 9x squared plus 4y squared plus 24y equals 0 is not quite in the format that I want. So 9x squared plus 4y squared plus 24y equals 0. The first term is all well and good. I do have something there, and I can maybe write that as, say, 3x taken to the second power. That's fantastic. But the other pieces I have here are two terms of y. I want that to be one thing taken to the second power. So I'm going to have to manipulate this equation in a way. Now, I do see that these two terms do have a constant in common. I should be able to factor out a value of 4 out of both of these values. And I can write this instead as y plus 6y equals 0. And you'll note that I left a space there. The reason for this, or y squared plus 6y, the reason that I left this as a space is because this expression looks like the first two terms that would come out of a binomial taken to a second power. For example, a plus b taken to a second power, that is a squared plus 2ab plus b squared. We have a squared, we have this second term that involves just y, or a, but we're missing this last term, which should probably be a constant. So we need to figure out what that constant is that would be missing from this. We may be able to manipulate it back into a quantity taken to the second power. This concept is also sometimes known as completing the square, as we are completing the expression that would involve a squared binomial term. So let's do that. Now, if 6y is supposed to be 2ab, and we called a squared equal to y squared, then that means a is just y, and therefore, in this equation there, I could also just say that 6 is equal to 2b, as y is taking up that variable of a. Meaning, if I need to figure out b, I need to simply cut 6 in half, which will give me 3. That is the number in my expansion of the binomial. Here, that would be 2 times y times 3. That does indeed give me 6y. And it'll also be the number that I will have to square and include into this expression. Is the number that I need to add to this in order to complete the square. If I have that plus 9 inside the parentheses, then I can revert that back into a binomial term squared, a plus b squared, which in this case will be y plus 3. However, I cannot simply just add 9 to the left side and call it a day. Keep in mind that this is an equation. We have to keep equality. If I'm adding 9 to the left side, I need to do something to the right side for equivalence. However, I'm not just going to add 9 to the right side, because that's technically not all that I did. I did add a value of 9 on the left side here, but that 9 is itself being multiplied by 4, since it is inside a parentheses that's being multiplied. So I need to add 4 times 9, because realistically what I added to both sides is 36. So I need to compensate for that. And there, I have now completed the square and can try to manipulate this. If I do so, that'll give me 9x squared plus 4 times this expression equals 36. And this expression, y squared plus 6y plus 9, I can simplify that down into y plus 3. Notice that that is the term to the second power for the first, so y squared gave us our first term, and then 3 squared gives us our second term. It's also the value of b that we had just solved for. Now, that's all well and good. That's now starting to look like something taken to the second power on both sides. But keep in mind with my original, I am trying to make this equal 1. Currently, that does not equal 1. And I could manipulate this equation and make it equal 1 in a couple different ways. I could try to, like, say, subtract 35, but what I will do instead, so I don't introduce another term to the left, I just manipulate what's already there, I will divide both sides by 36. If I do that, 36 divided by 36 is 1. And on the left side, 9 over 36 will give me x squared now over 4. 4 over 36 will now give me y plus 3 to the second power now over 9. And now I'm all set. I now have two terms that I can say are to the second power equaling 1. If I put this into the setup here, x squared over 4, if I factor out the exponent there, that is really x over 2. And then for the second term there, I'll have y plus 3 on top, that is taken to the second power. And on the bottom I have 9, which is 3 taken to the second power. With those in place, I can now relate them to sine squared and cosine squared. And I really could relate either one to cosine or sine, but based on the question that asks us to relate x with cosine and y with sine, I will connect these expressions together and I'll connect these expressions together. You could also think about it as I am rewriting this as cosine squared of t plus sine squared of t. Still works. With that, then, I now have an equation of x over 2 is setting it equal to cosine of t. And with the second set of equations, I have y plus 3 over 3 is equal to sine of t. Note that because both expressions were taken to the second power, I can drop that. And we can now solve for x and y. If I solve for x in the first equation, I will simply get x equals 2 cosine of t. Or if you want to write that like the method that they ask for, you could say 0 plus 2 cosine of t. And for y, if we multiply by 3 and then subtract 3, that'd be minus 3 plus 3 sine of t. This would be my set of parametric equations that are creating the exact same shape. In this case, this is creating an ellipse. This is an ellipse because, as per my equation that I made after completing the square, I have different radii along x and y. X has an internal radius of 2, y has an internal radius of 3, so it's stretching a little bit more vertically than it is horizontally. If those denominators were the same number, then it would be a circle instead. But that is all I really need to do here. Note that in some questions that you will see like this, you do not need to complete the square. It may already be done for you. I demonstrated here what would happen, though, if you did need to take that extra step.